Alright. Okay, can you see my slide now?
Yes,
Yes,
sir.
sir.
Alright. So just recap back. Okay, we have covered the introduction. The introduction for chapter 5. This one. For today, we will finish the other three subchapters, which is quite related. So we will finish this one today, and I will show a few examples, and we will finish for the class today. And the next week, the next 2 weeks, we will do more tutorials for other chapters as well, chapter 3, 4 and 5, just to recap back what we have learned during these 14 weeks. Okay, so this one I have done. Alright, so similitude, alright, is just the same with simulation. Simulation. Saya allow people dulu. Okay, so in most experiments, like we have discussed in the first class, to save our time and cost, so we will do the modeling first. And in any construction or in any you want to make anything, car or whatever, so commonly we will make the model first, and just to save our time and the cost, and before we do the real one or the prototype. Okay, so that's similitude. Okay, or which we mostly heard simulation. Simulation. So we try to simulate first. So the principle of this similarity, when we do the modeling, okay, so we need to make sure our model is the same with what we want to do in real. And when we want to make it, so we must make sure there is the geometry. There are three aspects that we must ensure that they are the same. So that these are the principle of similarity. So there are three necessary conditions for complete similarity between a model and the prototype or the real one. So the first one is the geometry, of course. If you want to make a car, so that geometry for the model and with the prototype or the real one must be the same lah. You cannot have the model with a different in geometry in modeling and with your prototype. So that's not a simulation. That's not a similitude. You must make sure the geometry is the same. Okay, so that's the first one. And that geometry must be scaled with the constant scale factor. And if you haven't see a drawing, okay, let's say a construction drawing, you want to build a house or school or whatever, they must have mentioned in that drawing the scale factor, one satu nisbah 200 ke, satu nisbah 300 ke. So that scale factor of your drawing with your prototype. Okay, so you must have that constant scale factor. Okay, I think we have seen this before, and when you did in subject drawing, or I'm not sure whether you have learned about drawing subject. Ada kan dah pernah belajar drawing before this? Pernah
Pernah.
Okay, so you must familiar with the scale, the scale factor. Okay, so that's the same lah with modeling with the prototype. Okay, so that's first, the geometry. The second one is the kinematic similarity. What it means by this is that the velocity at any point in the model flow must be proportional to the velocity in the prototype flow. If you make a boat, for example, before this I show you the picture of a boat, the Navy fleet something. So that velocity of that model, okay, must be proportional with the one that you want to build, the prototype or the real one. So same, kinematic similarity must be the same, modeling and the prototype. Okay, And the last one is the dynamic similarity, which about the forces in the model. If you have the model, you have the car or the boat or whatever, so all the forces dalam that model ada viscous ke, drag ke, whatever, so that forces, the value of that forces must be also proportional to that your prototype with a constant factor scale factor sama geometry, kinematic, dynamic. So there are three types, there are three conditions that you must ensure that these three have a similarity between your model with your prototype or your the real one. And okay, for example, this if you make a car, so this is your model car, so the small one. Okay, you want to cut the cost, cut the time, so you make a model first. But the geometry of this car must be the same with the scale factor to the prototype. Okay, so you might have the scale factor to 20 or 40, so that's your scale factor lah. So must be the same for your tire, for your door or whatever, so must be the same scale factor lah. Okay, so that's geometry similarity. And you have the kinematic similarity, which is the velocity. The velocity of this car must be proportional to your prototype. Okay, and the last one is dynamic similarity. It's about the force. Okay, you have the drag force or whatever force in this model, so you need to make sure it's also with the constant factor with your prototype. Okay, so that's the basic principle of any simulation. Okay, right. So that's simulation, similitude. So we have discussed before in this chapter is about dimensional analysis kan. Okay, why we want to analyze this dimension, because we in any building or in any drawing, in any construction, so we have the modeling and also the real one. So there must be a connection to this model with the real one kan. So there are that's the dimensional analysis So to get that, okay, to do this dimensional analysis, so we need to generate a dimensionless parameters. Okay, what we call as dimensionless parameters. Okay, so we will learn today how we can generate these dimensionless parameters in any equation, in anything. We have seen before a lot of equation. Okay, so there must be dimensionless parameters, okay, that can help us to know the right equation for that problem. Okay, so dimensional parameters are combined set of parameters which includes dimensional variables. Okay, there are the first one, dimensional variables, non-dimensional variables, and the third one is dimensional constant. Okay, so you have seen before, let's say equation I cannot think. Okay, there must be three at least three of these things, dimensional variables, non-dimensional variable, and dimensional constant. So what are these? The first one, dimensional variable, is dimensional quantities that change or vary in the problem. For example, length or time. Okay, length, time, mass. Okay, so that's dimensional quantities that can change or vary in your problem. So that's the first one, dimensional variables. The second one is non-dimensional variables. This is the quantities that change or vary in the problem but have no dimension. For example, angle of rotation, or before this we learned about Reynolds number. You have a equation that include the Reynolds number, so that Reynolds number don't have any dimension. Okay, so that's one of non-dimensional variables. And the third one is dimensional constants. Okay, so this dimensional constant is quantities that have dimension but remains constant in that problem, in that equation. For example, the G, we have seen a lot of equation that you used before, and you use the G, and the gravitational acceleration constant. G has a dimension meter second -2, but it remains constant in the equation kan. So that is a dimensional constant lah. Okay, G and G. Okay, this may be another one you are familiar with, the Knox number. Okay, this is length, time and mass lah. Okay, so these are the three dimensional these are the three parameters in a dimensional parameter. Okay. Okay. So during dimensional analysis, okay, to find that dimensionless parameter, so we represent this dimensionless parameter using uppercase Greek letter pi. Okay, you will see after this a lot of pi lah. So this pi is the dimensionless parameter lah. We equate this dimensional parameter as pi. Okay, that's why you will see the method. Saya so you will see after this a lot of pi in the equation, and that is because we will use a method what we call as the pi theorem, okay, to find this dimensionless parameter. Okay, in a general dimensional analysis problem, there is one pi that we call as dependent pi. Okay, so pi 1, so this is dependent variable. Okay, that means this thing, this variable is depend on something. It is not stand on its own. It depends on other parameters. So that's why we call it is a dependent pi, the pi 1. So the parameter pi 1 is in general a function of several other pi's, because it depends on other parameters. So it depends on the other parameters where we call as independent pi. Okay, pi 2, pi 3 or pi 4 lah. Okay, you might think quite confused or whatever. Okay, but we will see, because there are a lot of wording. Okay, no, don't worry. Okay, you will see it clearly when I show you the problem inside this chapter lah. When you use this dimensional analysis to find the dimensionless parameter. Okay, so now I just explain to you the theory behind that. Okay, so you have the pi 1, where we call as dependent variable. Dependent variable, so it depends on something, and it depends on other set of parameters which we call as independent pi's. Okay, so pi 1, okay, for example this function relationship, so pi 1, so this is the dependent variable, and this dependent variable is depend on other independent pi's. So pi 2, pi 3, pi 4, it could be anything lah. Okay, so this is the relationship lah. Okay, common established dimensionless parameters encountered in fluid mechanics and heat transfer are shown in the appendix section. You can see from this appendix. Okay, you have seen this before, might be you have seen a few of them. Okay, Darcy, previously in chapter 4 when we discussed about the losses and how to calculate the major losses, the minor losses, we use the Darcy friction factor the F. Okay, so this F has no dimension, it's dimensionless parameters. So this is one of common established non-dimensional parameters that you have seen. You may say Archimedes number, apa lagi yang biasa kita nampak, drag coefficient, okay, Euler number, Fourier number, Freud number, apa lagi yang awak familiar Reynolds number. So this Reynolds number, the previous chapter 4, we have find this Reynolds number is dimensionless. Okay, and so there are a lot of common established non-dimensional parameters. Okay, so mostly named by the person that introduced that parameters lah. Reynolds number, okay, fruit. So you can I'm not sure. Maybe in the future, some of you find discover a new number, the new dimensionless parameters that we can use in any problem or any equation and name by your name or my name. I'm not sure. Okay, we can. Okay, there are a lot of non-dimensional parameters that is commonly used in fluid mechanics. Okay, so there are the example of dimensionless parameters. Okay, so the most popular method used to generate these dimensionless parameters is called the method of repeating variables and the Buckingham Pi theorem. Okay, so we will learn this, how we can use this method to generate the dimensionless parameters in any problem or in any equation in any problem So we might not know the equation for that problem, so that's why this method will help us to generate that dimensionless parameters that we can use in that problem, in that fluid mechanical problem. We can use this method. It's very useful. That's why we will learn this, how we can generate that. Okay. So there are 6 steps. This method of repeating variables and the Buckingham Pi theorem. It is introduced by one researcher named Edward Buckingham. So he introduced this method. So there are 6 steps that involve in this method of repeating variables. You need to familiar with. That's what we will learn today. So the first step is list the parameters in the problem and count their total number of that parameters. Don't worry, I will explain first and then we will look the example of how we can use these 6 steps to generate that dimensionless parameters. The first one, list the parameters, what is in that equation, in that problem, what are the parameters that are in that problem. So list that, everything, and count the total number of that parameters, where we denote it as n. N will be the number of parameters lah. Number of parameters. The second step is the list the primary dimension. We have learned in the first class the primary dimension, where we learn about M, L, T tu kan. Yang ni, this one. So this is the primary dimension. So you need to list the primary dimension for each of the parameters. In the first step, so you list the parameters. For example, you have the parameters is length or velocity or density, whatever. The second step, list the primary dimension for these parameters. So for length is L lah, for V L T minus 1 hand. So you need to list the primary dimension of each of these parameters. So that's the second step. So the third step, we will set the reduction J as the number of primary dimension. In the second step, when you list the primary dimension, so you will count how many primary dimension is there in these all parameters. For example, let's say there are 2 primary dimension, L and T. So this is your number of J is the number of primary dimension. Number of primary dimension. So let's say you have 2 J's. The primary dimension, you list for all the parameters. So there are only 2 number of primary dimension, the J. So you will calculate number of K. Number of K will represent you the number of pi that you will generate. Number of pi Okay, k equal to n minus j. The n is here. When you count all the number of parameters, okay, you find 5 or 6, okay, and you minus with your number of primary dimension. This will give you the number of pi that you will generate inside the problem. Okay, number of pi, k number of pi. Okay, let's say you have 2 or 3, so this number will determine the number of pi that you will generate after this. Okay, so the fourth step is choose the repeating parameters. So there are a lot of parameters here. So you have 5 or 6, whatever. So you need to choose the repeating parameters. Okay, so this step I will explain later on. Okay, how we can choose these repeating parameters using the guidelines. This one, for step 4. Step 4. Okay, so I will explain this one later. Okay, and after you choose that repeating parameters, you will construct the pi that you have found here. So let's say you have 2 pi's, so you will need to construct the pi 1 and pi 2 lah. Okay, so you find this pi 1 and pi 2 if you have 2 pi's. If you have 3 pi's, so you have 3 pi's, pi 1, pi 2 and pi 3. If you have 4 pi's, then you need to generate the 4 pi's, pi 1, pi 2, pi 3 and pi 4. Okay, and the last step is that after you find all the pi's, you have generate all the pi, then you can write your final functional relationship and check your algebra. Okay, this is the last step lah. You will write everything, the equation, something let's say p equal to apa-apa, with using your pi. You have generate your pi here. This pi will be, you will write all everything to get the functional relationship. Okay, so that are the 6 steps. Okay, the theory you might not see it yet. Okay, don't worry, we will look it in the when we do the problem, we will see this one, these steps clearly lah. This all 6 steps, you will see it clearly. Okay, so before that, let me explain how we can choose this step 4. Choose this repeating parameters. Okay. Okay. How we can choose the repeating variables? Okay. Before that, in a question, in a partial paper or in the tutorial, normally they will provide you with that repeating variables. Okay. So they ask you, they mention in the question, let's say, take rho, take L, and take V as your repeating variables. Okay, if they mention in that question, so you don't need to use this guideline to choose the repeating variables because it's given in the question, and that is very common. Normally they provide you with. Okay, but in case they did not provide you with that repeating variables, okay, I'm not promise you that all question give you this repeating variable. There always one time that they did not provide you with this repeating variable. So you need to know how we can choose the right repeating variables in step 4. Okay, so these are the guideline. Okay, there are 8 guideline. Okay, there are a lot of guideline. I'm not sure whether this guideline is provided to you in the question. I don't think so. So that means you need to know this guidelines lah. Okay, you need to understand this guideline. Okay, take for example this problem. I give you this picture here. Okay, buruk pula. Okay, if you have any question, just ask, don't worry. Okay, we will learn this together. Okay, let's say this example, the diagram here, figure 7.23 is from the book. Okay, from the this textbook. Okay, and this textbook is available in your library. Okay, Okay, set up for dimensional analysis of a ball falling in a vacuum. So there is a ball falling in a vacuum. Elevation z is a function of time. Okay, so they gave you the z elevation of ball. Is a function of time t. I write here, kat sini nampak sikit. So z. Okay, and they mention it is a function of f. So function of time t. Initial vertical speed, okay, w naught. Okay, initial elevation z naught, and gravitational constant g, okay. So this is your first step, which I mentioned here. List the parameters in the problem and count their total number of n, number of parameters. So you have 1, 2, 3, 4, 5. 5 parameters, and this z is the dependent variable. Dependent variable. Bila saya we discuss here this not this one, mana? Here, kat sini the dependent variable. So this pi1. Okay, so this is your dependent variable because this z, it says here the elevation z is a function of time, vertical speed, initial elevation, and also the g. So it depends on other parameters. So this is your dependent variable, the z. Okay, and it depends on t, w naught, z naught, and g. Okay, so you have 5 parameters including the dependent variables. So 1, 2, 3, 4, 5. Okay, so your n number is 5. Okay, so this is the first step, n. And then the second step, you need to list the primary dimension of each the n parameters. So the second step, so you have z, and you have t, you have w naught, z naught, and g n. And you need to list down the primary dimension of these parameters. Z is the elevation height. So this will be apa primary dimension for z? Anyone? The primary dimension kat sini ni. This one. What is for z? The elevation. Anyone want to try?
Length.
Length. Yeah, length lah kan?
Length.
Yes. Okay. So the primary dimension is L lah. Okay. The length in meter, height in meter. Okay. So the primary dimension for Z is L. Okay. And you need to do for all of the parameters. For T is time lah. T. Okay. And W naught is the vertical speed. The speed. And we know speed is L T minus 1. Kan? Betul? Speed velocity lah. And Z naught, again Z naught is also elevation, which will be also L. And G is acceleration, the gravitational constant. We know acceleration is LT minus 2. So this is your second step. You need to list down all the primary dimension for all these parameters. Okay. The step 3. Okay, you need to find the number of k, number of pi. Okay, and the number of pi is k equal to n minus j. Okay, the n is 5. What about j, the primary dimension number? What is j? Can someone tell me? Just guess or try. Number of J. Number of J is the number of primary dimension. J here in this step. The second step, you have list your primary dimension. So what are the number of the primary dimension for these parameters?
5.
There are 5 parameters, but how many primary dimension that you use? 2 kan? L and T. L and T, T, L, L and T. So there are only 2 primary dimension for all these 5 parameters. Do you get it? This primary dimension number ni is just number of the primary dimension that you use. There are 5 parameters with respective primary dimension, and the number of the primary dimension that you use is only 2, L and T. And there are 7 kan, 7 primary dimension kan. So there are 7 primary dimension, M, L, T, T, I, C and N. Okay. So in this example, in these parameters, it only use 2 of that primary dimension, L and T kan. So your J number is 2. Boleh faham kat sini?
Boleh sir.
Boleh. So J, remember J is the number of the primary dimension. Okay, not the parameters. This is 5 is the number of parameters. J is the number of primary dimension. Okay, so 5 minus 2, it is 3. So you will expect that you will need to generate 3 pi's in order to solve this equation. This equation. So you will have pi 1, pi 2 and pi 3. Okay. So I want to explain to you about the step 4. Step 4 is choose the J repeating parameters. Okay. So now you want to choose these repeating parameters. Yang ni ada 5 parameters ni. So you need to choose 2 of the primary parameters, and because there are 2 primary J ni, J2 kan. Ada 2 primary dimension. So you need to choose 2 of these parameters in step 4. And how to choose that? If they're not given in the question, you will refer to this guideline. Okay. So you need to choose 2 kan. In step 4, choose 2 repeating parameters. Okay. How we want to choose that? So these are the guidelines. So number 1, never pick the dependent variable. So this is the dependent variable kan, Z. Ini kan. So you cannot choose this dependent variable. Okay. Never ever pick the dependent variable. So that's the first guideline. So that will leave to you only 4 Ada 4 parameters T, W0, Z0 and G. Okay. But you need to choose only 2 because your J number is 2. Okay. So the next guideline is the chosen repeating parameters must not by themselves be able to form a dimensionless group. Okay, what it means that this kat sini the other 4 available parameters ni, they cannot you cannot choose that parameters that can form dimensionless group. For example, kat sini tak ada, semua tak boleh form dimensionless group. Okay, that's why they comment here. Okay, if let's say you have to pick 3, let's say your J number is 3. Okay, let's say for example 3. So you need to choose 3 3 repeating parameters. And if you choose T, W0 and Z0, okay, T, W0 and Z0, these 3 parameters, if you look the primary dimension, they can form a dimensionless parameters by themselves. If you look for this equation, T times W0, so T is T is T times W0 is L T minus 1 divide by Z0. with L. So if you measure the dimension, it can cancel out everything, and L with L, T and with T minus 1. So this will form a dimensionless parameters and dimensionless group. So you cannot choose that three, T naught, T, W, L and W naught. So that's why it says here, the second guideline, don't choose repeating parameters that can form a dimensionless group. Okay, so that's the second guideline. So the third guideline, the chosen repeating parameters must represent all the primary dimension in the problem. Okay, in your second step, when you list down the primary dimension, so you have L and you have T. Okay, so you need to choose parameters that represent all of these primary dimension. So you need to choose at least in this line W naught, and other one is T lah, but we cannot choose Z. Okay, so you can choose W naught or Z naught that have the primary dimension. Okay, so you cannot just choose. Okay, let's say you choose two, kan? You choose only tak ada contoh. Let's say satu lagi parameter ni dia hanya ada L sahaja. You want to choose that parameter and Z. Both of them has a L primary dimension, so you cannot choose that because it not represent all the primary dimension. You don't have any T. Okay, so you need to choose that represent all the primary dimension. Okay, so that is the step guideline number 3. And number 4, never pick parameters that are already dimensionless. Okay, if you have equation tu ada constant, let's say bukan constant, yang dimensionless, tak ada dimension. For example, you have angle, so let's say comment they have an angle. Okay, let's say it also depend on angle. You cannot choose angle because angle don't have any dimension. Okay, or if you have any Reynolds number inside your equation, you cannot choose Reynolds number because Reynolds number is already dimensionless. Okay, so never pick a dimensionless parameters. Okay, so that number 4. And number 5, never pick two parameters with the same dimensions. Okay, or with dimension that differ by only an exponent. Don't choose parameters that have the same dimension. Let's say L and L. Okay, in the example Z and Z, you want to choose Z and Z naught. But remind, Z is already cannot be chosen because it is a dependent variable. Let's say you have another Z, Z2 or Z1, also have primary dimension is L. You cannot choose Z1 and Z0 because both of them have the same dimension. Or you want to choose a dimension, a parameter that have the same dimension but only differ with the exponent. Let's say you have the angular speed, which is the T minus 1. So you want to choose that angular speed with T. So T and T minus 1 both are the same dimension, just differ in the exponent. So you cannot choose that. Okay, so that are the 5th guideline. The 6th guideline, whenever possible, choose dimensional constant over dimensional variables so that only one pi contains the dimensional variable. So for example, this one, if you choose time T, okay, if you choose T, you will in other parameters also have T, kan? Sini ada T, ni pun ada T. Okay, so dia tak salah, cuma it will not the wiser option to choose T because you will have repeating T in other parameters. Okay, so you cannot choose T lah. It's advisable not to choose T because in W0 you have T, in G pun you have the T juga. Okay, so you cannot choose that. Okay, and the 7th guideline, pick common parameters. Okay, this is the also very important guideline. Pick the common parameters, macam speed, okay, length, density, time, the most common lah, yang common je. Okay, So they mention here length, velocity, mass or density. Okay, so it is unwise to pick less common parameters like viscosity or surface tension, or ada pressure ke, if your equation tu ada viscosity, ada dynamic viscosity, ada apa surface tension. So it's not wise to choose that because it is not common parameters. Okay, choose the common parameters first. Alright, and the last one, pick simple parameters over complex parameters whenever is possible. Okay, it's better to pick parameters with only one or two basic dimension. Okay, whether length or time or velocity, instead of parameters that are composed of several basic dimension. Apa kalau ada pressure tu force over area kan, you have a lot of apa primary dimension. So it's apa, pick a simple one. Okay, time or velocity here kan. Okay, so according to this guideline, what do you think that we need to choose for this problem? We need to choose two. Okay, T, W0, Z0 and G. So what do you think that the two parameters available that are the best option that we can choose as our repeating variable? Anyone? Nak dua? Any guess? Macam mana? Can we choose two variable here? T or W0 or Z0 or G? What are the two variable that is the best to choose?
W0
W0, okay, that's good. Okay, one is W0, the cost, and what? Okay, and
G.
And G. W0 is correct. Okay, but you have a more simple parameters that you can choose compared to G. G because you have apa LT minus 2 kan. So apa in 7 and 8 guideline they ask you to, as a guideline, pick the common one and also the simple one. So you already choose W0. So this already have satisfy the apa represent all the primary dimension. The step 3. So you need to choose repeating parameters that represent all the primary dimension. So you have to choose one, W0, which has all the primary dimension, L and T. That's good. Another one,
T.
T. So you have T here as well in W0, and T also have here in G. So the wiser option is Z lah, Z0, because it's only L, okay, and it is most common parameters, more common. You only need to choose two, so we will choose W0 and Z. W0 and Z0 lah, Z0. Sorry, L ni dimension, primary dimension there, okay. So these are the two primary repeating variable that we will choose according to this dimension guideline in order to help us to solve this equation, this problem. Problem sini. Okay. Why we don't choose T? Because it already mentioned here. If you see the guideline number 6, okay. If we choose T as repeating parameters in the present problem, it would appear in all 3 pi. Kalau pi 1 akan ada T, and pi 2 bila awak tulis pi 2 pun nanti akan ada term T. In pi 3 bila awak tulis nanti akan ada juga pi T, because already have in G, W and Z. Okay, so that's why we choose T instead of T in this 6 guideline. It is not wrong, okay. If you choose T, maybe you want to choose T, but it will give you more not straightforward lah compared to if you choose Z0 which has the L. Okay, so that is how we choose in step 4 how we use this guideline to choose our repeating variable. And this repeating variable is how many of them you need to choose is depend on this primary dimension lah. If you have if your J is 3 and you have MLT for example, so your J is 3, so you need to choose 3 repeating variables. If your J is 2 in this example, so you will choose only 2 repeating variables. Okay, alright. I know it's quite confusing, but if you do that, if you see the example, you will see it's very straightforward, very easy lah. Okay, so I'll show you one example, one or two today, and we can do more lah in the next class. Right. So this one of example of the question in the past year. So some aeronautical engineers are designing an airplane. So this is the airplane, and wish to predict the lift produced by their new wing design shown in the figure given. Okay, they want to design an airplane, and this is the wing, and they want to predict the lift, the force lift, this FL. So they want to predict this one. So the parameters involved to determine the force lift for this FL on a wing are first the chord length. Okay, so this is the first, and an angle of attack alpha in a flow of free stream speed V with density rho, viscosity mu, and speed of sound c. Develop a non-dimensional relationship between the force lift FL and the other parameters in the problem. Okay, so the first step is you need to list all the parameters, all the parameters in this problem. Okay, so they say the force lift is a function of, okay, so it says here determine the force lift on a wing are the chord length, okay, the length at an angle of attack alpha, okay, in a flow of free stream speed V, okay, with density rho, so you have a rho, viscosity mu, and speed of sound c. Okay, that's all. So this is your equation from the problem. So they say the force lift is a function of the length, the angle, the velocity, the density, the mu, and also the speed of sound. Okay, can someone tell me what is the number of n here? The number of parameters. Any guess?
6.
6. How you find that? How you find 6?
The L
L
A V.
Ini awak cakap ini. Okay. It is almost right, but you forget this FL as well. So this also a parameters. This FL also a parameters where we call it a dependent variable. If it's dependent variable kat sini. Okay. Dependent variable ni kan, this one. Okay. So the F, the force lift is function of something tadi tu, time, everything semua. So the parameters semua ni lah, semua pi ni parameters. Okay. So we have 7 lah parameter 1 2 3 4 5 6 7 7 parameters including the dependent variable kat sini. Semua yang ada dalam problem ni, that's all the parameters. The n number of parameters kan. So the n is 7, not just 6. you have to include these parameters as well, the force lift. Okay? Boleh faham tu?
Boleh sir.
Okay. So that's the first one, the first step. So you need to list all the parameters, all the parameters inside this problem. The second step is you need to list the primary dimension again. List primary dimension of each parameters. Okay, so you have 7 parameters. So you need to list down the primary dimension. So you have FL. So normally I suggest you to draw a box. Okay, so L for the length, for the alpha, for the velocity, for the rho, for the mu, and for the C. Okay. So what is the primary dimension for F? The force. Apa primary dimension for force? Anyone? Ada yang boleh buat? Ada yang boleh ni? Want to try? Just don't worry, don't be afraid if you are wrong. That's a learning process. What is the primary dimension for F? F equal to F apa?
MA.
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 Okay. So you have already M, the mass lah kan? So you already have M. Kan? A, what is A? Acceleration.
V over T.
V
V over T. So
V
V,
over T.
apa dia punya dimension? V apa dia dimension V?
V S over T.
S over T, and that is L lah kan? L
L.
and T kan?
L over T square.
Okay, so for A, so jadi L over T lah. So L over T square kan? So that will be L T minus 2. Betul? Betul?
Yes sir.
Okay, so this is the
Yes sir.
primary dimension for force. So but I recommend you, advise you to write the number for M and L as 1. M1, L1 because this you will use that to calculate later on. So it's betul lah, this only M, L and T minus 2, but make it an as a process. You label every number of that primary dimension. For M is 1, L is 1. Okay, so that's why I write here M1, L1, T minus 2. Okay, how about for L? What's the primary dimension for L? The length.
L.
L. Okay, so don't forget to write L1 lah. Okay, L1 How about the angle of attack, alpha here? What is the primary dimension? Angle apa dunia ni, primary of dimension? Anyone?
Dimensionless.
Dimensionless. Yes, there is no dimension for angle. Okay, so there is no MLT, so you just can write 1 lah. There is no dimension. Okay, so just a trick. There is no dimension for angle. How about V, the velocity, the speed?
L T
L T negative negative.
L over
L
T.
T negative 1.
So L1 T
T negative 1.
1 minus 1. So don't forget, make a bit L1 even though there's not minus, just it's 1 lah L1 kan. Okay, how about the rho? the density. Remember, rho is mass over volume kan. Okay, so what is the primary dimension from there? For density. Okay, density.
M1,
M1, okay, good. M1.
L negative 3.
L negative 3, yes, that's right. How about mu? Okay, ini susah sikit lah, the viscosity. What is the primary dimension for viscosity? Viscosity is Pascal times second, kan?
M1.
M1, okay.
L negative 1.
L negative 1, okay.
T negative 1.
D negative 1, very good. Okay, so this is the primary dimension for mu. You can get it from this one. Pascal pressure lah, pressure F over A. Okay, so you find the primary dimension for F and A, and then for S lah, T ni T je kan. Okay, so you will get that for mu. And last one for the speed of sound. So what is the primary dimension for speed of sound? It is speed lah, velocity kan.
L T negative 1.
L1 T minus 1 kan. Okay, similar with the V lah So this is your second step So you need to list all the primary dimension for each parameters. Okay. Okay, step 3. It says in step 3 is you need to find number of K kan. Set the reduction of J as a number of primary dimension, and then calculate the K, the number of expected pi. Okay, so what is the value for your J here? Siapa boleh tahu? Siapa boleh beritahu number of J, the primary dimension?
Three.
3, correct. So we have M, L and T kan. Okay, so we have 3 primary dimension. So J is 3, and then to find K, K is equal to N minus J. Okay, K is number of pi lah, number of pi that you will generate in this equation. So N is 7, J is 3, so this will be 4. So number of pi that you will generate after this is 4 pi. So you have pi 1, pi 2, pi 3 and pi 4. Okay, so you have N is equal to 7, J equal to 3, M, ada L, ada T. Okay, so that's why J is 3. Okay, so J is 3 lah. So 7 minus 3 is 4. So you will expect to generate 4 pi in this equation. Okay, the fourth step is that you need to choose this repeating variable kan. Choose repeating variables. Okay, how many variable that we need to choose? Ada 7 ni, kan 7 kan? 1, 2, 3, 4, 7. So how many in step 4 that we need to choose this repeating variable? Berapa kita nak pilih? Ada siapa ingat? Kita pilih berdasarkan according to what number? Want to try? J. Okay. Your J will determine how many repeating variable that you need to choose in step 4. Okay, remember this. So you have J number as 3. So you have M, L and T. Okay, so you have 3 J. So you need to choose 3 repeating variable from these 7 parameters. You get that? Boleh?
Boleh sir.
Okay.
Boleh sir.
Boleh sir.
To choose repeating variables, ada guideline dia lah. Tu guideline nak pilih. But how many variable that you need to choose? it depends on your number of primary dimension, J. Okay, so you have 3J, the J is 3, so you need to choose 3 lah from this 7, FL or LC or alpha or V or rho or mu or C. Okay, so the next the next step is which one that you want to choose in these 7 parameters. So this is the tricky one lah, not tricky tricky jugalah okay, if they don't provide you in this question, okay, they not mention anything, choose what repeating variables. So this depend on us to refer to the guideline which one that you will choose from these 7. Okay, so how we can choose that 3 repeating variables, which one that you want to choose? Okay, refer to the guideline. They said you cannot choose the FL again. Betul? Betul tak? Tak boleh.
Betul.
Sebab
Yes,
apa?
sir.
Why? Why we cannot choose the FL? Why we cannot choose the FL?
Dependent variable.
Yes, because FL ni dependent variable. Okay, it is dependent variable and it stay here in the guideline number 1. Never pick the dependent variable. Okay, so you cannot choose FL. So you cancel out the FL first. Okay, throw away the FL. So you will have another 6 to choose. Okay, you want to choose 3, eh? Okay. Now, so you have cancel out FL. Ini tak boleh pilih. And in step 4, you in number 3, okay. So choose the repeating parameters that represent all the primary dimension. Okay. So you need to choose at least one yang ada all the primary dimension. Okay, ada M, ada L, and ada T. Okay, so you need to choose that parameters that will give you the primary dimension. Okay. Okay. So and this mu and viscosity is what we can consider as more complex, kan? Okay. It says here never pick the complex one. Choose the common one. Choose the common parameters and don't choose the complex parameters, kan? So we can throw away the mu because this is not very common. Okay, it's complex. It's quite complex. So we can cancel out the mu. And it also say here that you cannot choose the dimensionless. Okay, so which one here is the dimensionless parameters? LC alpha, kan?
Alpha.
This angle is dimensionless. You cannot choose this dimensionless parameters. Okay, so we can remove that alpha. Okay, so now leave to us only L, velocity, and density, and also speed of sound, the velocity. Okay, and V and C ni the same, kan? Same dimension, kan? So they ask you, they mention in the guideline never pick the same with the same dimension, kan? Never pick 2 parameters with the same dimension. Okay, so either you choose C or V. So anyone lah, anything, any one of V and C. Only choose one. Okay, you cannot choose both. That means you can cancel out any one of them lah. So I will cancel out the C. Okay, because they the same ni, kan, same dimension. So it leaves to you only L, V, and rho. And this is your repeating variables L, C, V, and rho. And these are 3 variables that you will choose. And these are common, length common, velocity common, density common. So you will choose LC, the length, and the velocity, and also the density. Okay. Do you understand that? How you choose that repeating variables?
Yes, sir.
Is it more clear or still unclear? How to use this
Dah
guideline?
boleh faham sikit dah.
Boleh So if you read this guideline, you might be not see it clearly, but when you do this question, I show you the example. Now you will see it clearly again. Okay, now it's left to you only LC, the length, the velocity, and also the row. That is step 4. Okay, step 5. Step 5 is that you need to generate your pi kan? Generate your pi lah. Okay, so you have 4 pi. Okay, that's ni. So 4 pi, pi 1, pi 2, pi 3, pi 4. Okay, how to generate this pi is very easy. Okay, so now you do one by one. Okay, pi 1, pi 2, pi 3, and pi 4 lah. Okay, so now we do for pi 1 first. Okay, pi 1 will equal to okay, look from these parameters. Okay, so now your repeating variable is L, V, and rho kan? Betul? 3 repeating variables kan? So you have 4 that is unused, the FL, the alpha, the mu, and the C. Okay, 4, 1, 2, 3, 4. So this will represent your pi after this. Okay, so that's why for the first one, the FL, for the first pi, you will write as pi 1 equal to FL times your repeating variable. Repeating variable is L, V, and rho. So V, and you will write denoted as A1, V, L, the LC, and this is will be 1, the power of that, and rho, you will write it as C1. Okay, so pi 1 will equal to the first and this one, the first unused parameter, the FL, times this 3 this 3 ni yang 3 itulah repeating variables V, L, and rho kan. V, L, V, and rho. So you will write that as in your first pi. Okay, and then pi. So we know the primary dimension will be is dimensionless parameters kan. So M0, L0, T0. Okay, this will equal to the FL. The primary dimension for FL is M1, L1, T minus 2. Okay, so you write that again. M1, L1, T minus 2. So this is for FL. Okay, and then for V, so V is L1, T minus 1. Okay, so L1, T minus 1, the primary dimension for V, A1. Okay, and for LC is L, so L1. Okay, the power is B1, and rho, you have rho is M1, L minus 3. Okay, and this will be C1. So why is this A1, B1, and C1? Because you need to find this number of this dimensionless parameter pi. Okay, so now you do for M. Okay, so 0 M0 dimensionless for dimensionless ni 0 will be equal to M1, so 1. Sebab tu that's why I ask you to write number 1 also in the number in any primary dimension. Even though M as only M, you need to write that 1 the power of that primary dimension because you need to write this equation. Okay, 0 equal to M is 1 kat sini 1. Okay, and apa lagi satu kat sini kan, M1 times C1. Okay, so this will be plus C1. Boleh faham tak apa saya buat ni? M for M. Anyone did not get this? Anyone get this? Tak ada juga.
Belum dapat sir.
Belum dapat ke?
Tak faham sir.
Okay, so this is your dimensionless parameters kan, this pi. Betul? The pi 1 will equal to the first, that apa, you have FL and you have alpha yang tak digunakan yang L, V and rho ni is your repeating variables. L yang ni L, V and rho is your repeating variable kan, that you choose already here. So you have FL, alpha, mu and C, the other parameters that you not use yet. Okay, so this will be used in your pi equation, because you need to write 4 pi's kan, 4 pi, pi 1, pi 2, pi 3 and pi 4. So these 4 unused parameters will be used in your pi equation here. Okay, so for the first one, so pi 1, so you will use the FL. Okay, first use the FL here times this repeating variable V, L and rho, and you will have this power for all of this repeating variable A1, B1 and C1. Okay, and there's dimensionless parameters here have M0, L0, T0 lah. Okay, so you can you will write the equation for M, so 0 equal to M1 plus ada M is di sini tak ada M kan, ni plus kosong lah. Right, saya tulis macam ni senang sikit. Pelan dulu. Okay, pen. Okay, in this equation for FL, so you have M equal to 1, so that is M 1. In V, so you don't have any M, so this will be plus 0, and in L you also don't have any M, so this will be plus 0, and in rho you have 1 M, M1, and this will be power to C1 lah. Okay, this just to donate. Why we write this? Because we want to find the power of that pi, apa power dia ke berapa. Okay, so you will find you will write this as C1 because you have M1 kat sini, and this will multiply with C, and this will be C1, and this we write as C1 will equal to minus 1 lah kan, C1 disambung kan, so C1 will be equal to minus 1. Okay, so this C1 will be akan digunakan kat sini lah, rho tu maksudnya consider minus 1. Okay, and you do the same for L, and now for L, so L0 equal to, in F you have 1L, so this will be 1. In V, so you have 1L, so A1, and L, so you have L, so this B1. In rho you have minus 3 times C, so this will be minus 3C1. Boleh? Nampak lagi can you follow this?
Boleh sir.
Okay, now because you know C1 is minus 1 kan, minus C1 is minus 1, so you can write this as A1 plus B1 will equal to, you bring this to the right left hand side, 1 jadi minus 1, this will be plus 3 C1 kan, and C1 is minus 1, so this will be plus 3, I just write so we can see it clearly, plus 3 times minus 1, so this will be A1 plus B1 equal to minus 4. Betul? Boleh?
Boleh sir.
But we don't know yet because we have two unknown, A1 and B1. So we do for the T after for T pula. So for T, okay, for T0 equal to, so we have 1T here and it's minus 2. Okay, minus 2 for F, and for V ada satu T, so this minus 1, so times A1, so this will be minus A1, and we have this is 0, tak ada, it's plus 0, and ini pun 0, plus 0 juga. So we know A1 will equal to, we bring A1 to the left hand side, A1 will equal to minus 2. Betul? Can you follow this?
Boleh sir.
So now we know A is equal to minus 2. We can find the B1 lah. B1 will be equal to minus 4 minus A1. And A1 is minus 2. So will be plus 2 lah. And so B1 will equal to minus 2. Okay. Boleh? Tak habis lagi ni.
Boleh sir.
Boleh sir.
Now you know A1, what is the value for A1? What's the value for B1? What is the value for C1? Now you can write your first pi as FL times V, the A1 is minus 2, LC, the B1 is minus 2 juga, rho C1 is minus 1. So now you know the dimensionless parameters here will be equal to, ini dah habis ni, cuma awak boleh tulis lagi sekali, FL, and because this is all minus, so you divide lah kan, betul? So it will be V squared LC squared times rho. So this is your pi, the first pi. Boleh? Boleh faham tak ni? Okay, you want to find the dimensionless parameters. Again, what are we doing is that we want to find the dimensionless parameters. This pi 1. If you write this primary dimension, the FL, V semua ni, if you do that, you will find that this pi is dimensionless parameters. All the primary dimension can be cancelled out, and this is the dimensionless parameters for pi 1. Okay? But you have 4 pi's kan? When you calculate, you have 4 pi's. So it's not finished yet. So you will do for pi 2 pula. So pi 2, okay. So we now have used the FL. The one that we after this we use the alpha lah. Alpha pula ni. Okay. So now for for pi 2, so you will write as alpha, again the repeating variable, so you have V, okay, so V will be A2 lah, A2 pula, tadi A1 dah kan, V, and then L, LC kan, so B2, and rho C2. Okay, so now we know the dimensionless parameters M0, L0, T0. Okay, this will be equal to alpha don't have any dimension, just like 1, and we know V have L1, T1, T minus 1, sorry, T minus 1, this A2, and L, LC as L lah, so L will be 2, and rho, we know rho is M1 and minus 3, C2. Okay, so again we do the same as tadi for M. Okay, for M 0, okay, m0 equal to, there's no m here, 0 plus, ini pun tak ada 0, plus 0 plus only m here kan dekat row. Okay, so we have 1m, so 1 plus times C2, so this will be C2. So C2 will be equal to 0 lah. C2 0 kan. Okay, that's for m. And for L, 0 equal to, so we have 1L here in V times A2, so 1 times A2, A2, and we have B2, so plus B2, okay, and another L here minus 3 kan, minus 3 times C2 minus 3 C2, and we know C2 is 0, okay, C2 is 0, so this is 0, so A2 plus B2 will be equal to 0. We have two unknown, we cannot solve this one yet, so we find for T. For T, 0 equal to T, here we have 1, minus 1 times A2, okay, so minus A2, okay, and L tak ada, row tak ada T, so A2 will be equal to 0 juga, betul? So now we can find B2 will equal to 0 juga lah, kan? So everything is 0, so that means our second pi will equal to alpha times V A2 0, LC B2 0, rho C2 is 0. So it will be just pi 2, it will be just alpha je lah, dimensionless parameters dia alpha je. Okay, and we do the third pi. Okay, the third pi I will write is here, the third pi. Okay, so we now have used FL dah, ni dah, and alpha dah. Now the third one is mu kan, mu and C belum lagi, so this your third one is mu. Okay, mu times again V, so A3 LC B3 times rho C3. Okay, so do the same, M0 L0 T0 will equal to we have mu is M1 L minus 1 T minus 1, so write that M1 L minus 1 T minus 1, okay, for mu, and then for V L1 T minus 1, this will be your A3, and L C lah times B3, and rho will be M1 L minus 3, so C3. Okay, so do the same again for M first. For M, this will be 0 equal to, so we have 1M here, so 1 plus, kat sini tak ada, LV tak ada M, 0, plus L pun tak ada juga, 0, plus rho ada 1 M, so C3 kan, so C3 will be equal to minus 1, and for again for L, so you have 0 equal to L minus 1 1, and you have another one kat sini, A3 plus A3, and you have B3 plus B3, so you have forgot to write 1 as here, and then minus 3, and minus 3 C3, so we can write this A3 plus B3 will equal to 1 plus 3C3, and we know C3 is equal to minus 1, so this will be 1 plus 1 minus 3, so this will be minus 2. A3 plus B3 equal to minus 2. Okay, then do for T. For T, okay, so T 0 sama dengan minus 1 minus A3 and that's all. This is 0, 0. So A3 will be equal to minus 1. So we know A3 is minus 1, so B3 will equal to negative 2 minus A3. Okay, so minus minus, so this will be plus 1, so this will be equal to minus 1. Betul? Boleh? So now you have find A3, B3 and C3. Now your pi 3 will equal to, okay, mu times V A3 is minus 1, LC B3 is minus 1 juga, rho C3 is minus 1. So you can write this as pi 3 equal to mu over V L rho. Okay, so this is your third pi. Mu over VLC, LC and rho. And you have one more pi, so I need to add more page there, and then we can finish this question again. This slide. Okay. Okay, now the fourth pi, we have 4 pi kan? So pi 4 will equal to, so now left, the last one is the C kan? C okay, last one will be C times the repeating variable apa, V, L and P kan? So V, so this will be A4, L, C, B4, rho C4. Okay, and you know the M dot 0 M0 L0 T0 equal to C, the velocity, so this will be L1 T minus 1. Okay, and V pun sama, velocity juga L1 T minus 1, so this will be A4, and LC will be L, so this L1, sorry, will be B4, and rho, you know rho is M1 and minus 3, this will be C4. Okay, do the same again, M for M, so 0 equal to M0, so you have no 0 here, 0 plus 0 plus 0, and you have M here plus C4, so C4 equal to 0 lah. Okay, and for L, so 0 equal to L1 plus A4, ada A1L, A4 plus B4 minus 3C4. Okay, and we know C4 is 0, so A4 plus B4, sorry, B4 equal to 1. Okay, and we have two unknown, so we need to solve for T first. So for T, so 0 equal to minus 1, okay, minus 1 minus A4 and 0 0 tak ada, so A4 will equal to minus 1. Now we can solve for B4, so B4 will equal to 1 minus A4, A4 is minus 1, so this will be 2 lah, 1 plus 1, so 2. Now the pi 4 will be equal to C times VA4 minus 1, LC B4 is 2, and rho C4 is 0. Okay, so this will be pi 4 will be equal to C over V, ya, LC ni katanya, LC ni sini, for L, so 0 equal to 1 plus A4 plus B4 minus 3C4, so A4 plus B4 C1 and C4 is 0. Oh, sorry. Sini salah kat sini kan. A4 plus B4 is equal to 1. It's not 1, it's minus 1. Betul? Can you get this? I'm wrong here. So should be A1, A4 plus B4 equal to minus 1 lah. So that's why B4 will equal to minus 1 minus, saya padam dulu. Okay, so that's why we need to be careful. So B4 will be equal to minus 1 plus minus A4. So this will be A4 is minus 1, so minus 1 plus 1 lah. So this will be equal to 0. Betul? So B4 ni 0 lah patutnya, bukan 2 0. So now you have pi 4 equal to C over V lah. Kalau LC is 0, rho also 0. Okay, so you have done everything for your all pi's, for 4 pi's, pi 4 ini, and you have find for pi 3 ni, and pi 2 ini. Okay, so the last step, the step 6, you need to write, okay, step 6, you need to write the functional form. Write the functional form. As we learn here, after you have find all the pi, you need to write this one. So pi 1 equal to f times pi 2, pi 3, pi 4, whatever lah, how many pi you have. So you need to write back. Pi 1 equal to f times pi 2, pi 3, and so on. Okay, how many pi you have. So now we need to do for our problem. So now we need to write back. Okay, sorry. So pi 1 equal to, we need to write in the form of this. Pi 1 equal to f times pi 2 times pi 3 times pi 4. Okay, so pi 1 is equal to this one. Okay, FL over V squared as C squared over rho. Okay, so this one will be FL over V squared LC squared rho equal to F, okay, pi 2. So we have pi 2 equal to alpha, and pi 3, we have pi 3 as mu over VLC rho. Okay, mu over VLC rho, and pi 4 we have C over V. So this is your final answer when you write your functional form for this force lift. Okay, can we any question? Can you follow this?
Yes, sir.
Boleh sir.
Boleh sir.
Boleh dia apa macam mana cakap, dia quite very easy. Dia tak ada macam-macam keperkiraan pun. Macam contoh apa chapter 3 and 4, you have a lot of apa find this, find that, but in this chapter 5, the thing that you need to be careful is macam tadilah saya dah ni kan, saya salah tulis A1 A4 plus B4, I write it as 1. So that's the thing that you need to be careful of. Write the equation nicely and calmly, don't rush. Okay, then you will solve the problem easily lah. Then you can write your functional form after you find all the pi. Okay, in this case I show you the example. It's quite long lah. Because you have 4 pi's. Maybe in other question you only have 2 pi. Then it's lagi pendek lah perkiraan dia, ada 2 pi je. In this example I show you, you have 4 pi, so you need to find pi 1, pi 2, pi 3 and pi 4. Alright, so this one I will show you in next class. There are more example. Okay, we can do this, or you want to do it on your own also can. Okay, but I will show you again lah in next class. Okay, any question or anything for this chapter 5?
No, sir.
No, sir.
Alright. Sorry. I think we can end our class. Okay. Thank you for your attendance. Please do the example or for your own learning process. We will do more in our next class lah, insyaAllah. Okay. Again, we will meet again on next week lah. Okay, next week we meet again and we will do more tutorial on chapter 5, insyaAllah. Okay. With that, I end the class. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.